Okay, first, how was the group meeting? I think I can actually schedule more and more group meetings, allow you to discuss any issues. And next, maybe down the road, I'm gonna actually assign you some of the work, and you can discuss certain chapters, certain sections. Then uh, each group may actually present some questions. I think this part of the um, exercises because I want you to be engaged, involved in any uh, topics in each of the chapters.
So the group lab on Zybooks isn't due yet, then, right?
The lab, uh, I think the lab is actually,
I
I
did the
think it's,
first one, but I think there's like another one that's assigned.
yeah, the programming lab. That's each of the assignments are basically individual assignment, but the group assignment is basically just for class discussion because I want you, before the class, I want maybe give you some kind of a reading assignment. Then you can have a group discussion, and each group may actually present, uh, post some of the questions, issues on the discussion forum, so we can use this uh, as a topics in our next class. Okay, yeah, I think the the programming lab is due on 12th. I think it's February 12th, but depend on the class progress. Um, I'm not going to actually ask you to do any kind of assignment way before the topic is covered. But sometimes I want you to actually, for some of the exercises like challenge activities and you know some kind of practice, I want you to actually, read it and do it even before we talk about it in the class. It's up to, it's depend on the topics. If I feel like a certain of the topics, it's easy for you to read and then do any kind of practice, then I probably gonna ask you to read and do the practice. Uh, I hope the class gonna only focus on some of the tough topics, something that the most of you have a problem with. Okay. And also, after we finish the module one, then I will spend more times on some of the examples. We're going to actually work more on example. The best way to learn programming is to do the programming. So that's still that's my philosophy. So that's why, chapter one is I try to finish up the chapter one because most of the concepts are basically the same as Python, if you already learned Python. So that's why I want to just go over with, and then starting from chapter 5, which is actually the module 2, and then we're going to actually do more practice. Okay, so I think so far we have discussed many of the topics, like we discussed data type. Can you see the screen yet?
Yes.
Okay. So we talked about the integer type and floating point. Okay, floating point type. So and then we also not spend much time, but we also discuss the characters. Okay, and also something we're going to talk about is also the string. Okay, these are the main data types we're going to talk about. And now in terms of Java, then the integer has various different variations in the Java, depend on how many space we want to reserve for that integer type, and how big the number we're going to discuss. So that's something we're going to talk about just today. Okay. And we also talk about various different operations. Arithmetic operation. Now these are basically the same as Python, so that's why we're not going to spend much time. Plus, minus, multiplication, division, and also the other operation some of you may not be familiar with is the modular operation, which is basically, the division and the modular operation are basically two operations related to the division. The division basically just do the division. So you divide one number by the other. So the modular operations actually apply to the integer types. So when you divide the two numbers, now a divided by b, and then a may not be completely divided by b because a is probably not a multiple of b. So then you may have a remainder. So these modular operation basically give you the remainder when you divide one number by the other. So talk about division. The division is actually very tricky operation because if you actually talk about two numbers, a and b, a divided by b, so the result depends on the type, the data type of a and b. If both a and b are integer type, so the result for the division is also integer. Okay. Now, how is that possible? Because sometimes a may not be completely divided by b. So a is 5, b is 2. So 5 divided by 2 is 2.5. How can I make it integer? So the way I can do the Java can do this is when a divided by b, 5 divided by 2 is 2.5, but because a and b are both integers, so the result has to be integer. Okay, so in that case, 2.5 will be forced to convert to integer. So in that case, 2.5 going to be 2 because they're going to get rid of the numbers after the digitals after decimal points. So now the only thing you can do a real division is if a and the b are both floating point. So then the result is going to be floating point. Okay. If both a and b are integer. Okay. If both a and b are floating point, then the result can be floating point. Now, so typically for an integer type, division and modulo operation basically are two operations. So division going to give you the, eventually, if for two integers, division going to give you the quotient. The modular operation going to give you the remainder. So these are two operations. So sometimes people take advantage of these two operations for the integer type. Okay. Now, the other important topic we just talked about is the import. Okay. So you can do the import by assignment. So x, if I say x is an integer, and then I can say x equals 2, then you can actually assign value 2 to x. That's one way to import a value. Now, the more popular way to do the import is using scanner. Okay, scanner is a class. Now, in order to use the scanner to import the class, import a number or import a character, so it's a way to import the data. Okay, now scanner is a class. So in order to actually perform the import, the scanner allows you to import value from the prompt. So then you can actually, the scanner basically going to actually, lead you to a prompt. So you can actually type the values you want to import into the into the program. So when you do the scanner, you need to first define an object, we call it, because the scanner itself is a class. You need to define an object. So the object name could be any name, but mostly in this class, we use SCNR. I don't know why they always use SCNR, but you can use actually whatever the names you want to use. Say scanner, and you can say my scanner or whatever. So then you're going to say, okay, define this object, and then new scanner, and then in most case you put the sys.in. Okay. And then you can actually use the scanner object to import a value. If you want to import an integer type, you can use scnr, which is the object of the scanner, next int, that's capital I. Okay. And then once you actually use this scanner object next int to import whatever the value you just typed in, it will be imported as an integer type if you use next int. Then the value going to be assigned to any variable you put on the left. So, but you have to define x as integer type. So you can say scnr next int, and this is going to actually read the value you just typed in from the prompt and assign to x. Okay, so this is actually the the scanner, scanner, and how it gonna actually import integer value. Okay. Now you can also import a floating point. Okay, so then you can say double y, and then you can say y equals scnrs dot next double. So this will allows you to read the prompt, whatever you typed on the prompt, the any floating point number you typed, like a 2.57, and then this number you typed will be read by the scanner object, and then assigned to type Y. Scanner also, you can also use a scanner to import a string. This is actually initially designed for this originally designed for scanner. You can type scanner. Okay, but before this, you have defined a string. Okay, string type. So that's something we're going to talk about today. Okay. Now, before we do this, I'm going to actually talk a little bit about the binary. Does everybody know anything about the binary number?
I mean, I've heard of it from last year.
Okay, yeah. So let me actually, I'm not going to spend much time, but the reason for this is because the binary, when we do the programming, we may not need to know much about the binary, but if we want to know how the computer actually store a data, then you have to know the binary, because every data going to be eventually stored in the computer memory, and then they're going to be stored as a binary type. Okay. So the binary is actually a numeric system that they only use 2 digitals. Okay. 0 and 0 and 1. Okay. Let me. Okay. Okay, so so binary only has two digitals, 0 and a 1. Now, the I think now it's actually a numeric system. It's a number system that used by computer system. Now, the number system we are using now, it's called decimal. Okay, decimal system. So in a decimal system, we basically use 10 digitals, or we can say 10 different symbols. We call it Arabic numeral. So 0 to 9, it's a 10 different one. But the binary use only 2. Now, this is going to make a very big differences. Even though technically binary and digital are some sort of equivalent, because any number written in binary can be converted into decimal. Any decimal number can also be converted to binary. Now, the difference is actually because decimal is actually use 10 digitals, and we call the base 10. And this is base 2. Now, how is different? How is that different? So when you count a number, when you count a decimal, then you're going to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, depend on how many, what's the number is. Now, once you got a 9, and if you want to add an additional number, then we run out of symbols because I cannot use any new symbol to represent 10. So I have to reuse the number. So in that case, when you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then if we want to count 10, then we actually going to use a different positions to provide different meanings. Now, everything actually right on this line, we call it ones position. Now, if you want to represent 10, then we want to use a different position. So I'm going to say, okay, 10, that means I'm going to actually, reset the number to 0. Okay. Reset one's position to 0, and I just add a 1 over here. That's a different position. So in that case, this position is called a tens position. Okay. So now 1, 0 means 10. Now in that case, I reused actually existing symbol from 0 to 9. So 1 is here, 0 is here. So 1, 0 is not new symbol. Okay. So now if I count another 1, add another 1 on the 10, then I got 11. So I just keep increase the ones position until I got a 1, 9. Then if I want to add another number, then I cannot continue because 9 is already the largest one. So I just reset to 1, and then I'm gonna add another 1 to the next position, the 10th position. Now since there's already a 1 here, adding another 1 gonna make it 2, right? So I'm gonna got a 2, 0. So that way I can actually continue to count the number every time. When I count the numbers 0, 1, 2, 3, 4 all the way to 9 in one's position, and then if I add another 1, then I can actually reset it to 0 in one's position and then add a 1 in 10th position. So that means every number here in 10th position represent 10. Okay, so number 2 in 10th position is not a 2. It's actually 20. Okay, it's a 10 times more than 2. So that way I can just continue to count. So once I actually count all the way to 99, so then I'm going to say, okay, if I add one more, then I have to reset to 0 and add 1 to the next position. And the next position, 1 plus 9, again, it's more than 9. So I can put a 0. And then I add another 1 in a next position. So I create another position. That's called a 100th position. So that means that 1 represents 100. So this is actually how the decimal actually works. Now the binary is kind of same way. So when I count 0, 1, and then I'm running out of symbol. So I reset to 1's position to 0, and I increase to put the 1 over here. So this is called a 2's position. And this is 1's position. Okay. So then the next one is 1, 1. And then I'm running out of again. So 0, I'm going to add a 0, 0, 1. And that's called a 4th position. Okay. So that's that way I just doing the binary. So the binary and the decimal can be, they're interchangeable. Okay. Now, the reason we introduced this is because each memory location is composed of bits. So that means you can store 0 or 1. So you can only store a binary numbers. Okay. So that's basically the concept of binary numbers. Now, if you actually already work on the Zybook, the exercises in this binary, you probably actually can see one of the practice just allows you to do the conversion between binary and decimal, which is pretty cool. Let me actually show you. Yeah, this is actually the participation activity. This is pretty cool. You can practice this. For example, you can setting a binary digitals and figure out what is the decimal value. So if you put the 1 here in 1's position, then the decimal value is also 1. However, if you put the 1 here, so the decimal position 1, 0 for the binary is decimal value 2, because as I say, this is 0. Okay. Because this is 0. This is 1. And this is 2, because that 1 represented 2's position. So this is 2. So this is actually 2. And this position is actually 4. And this position is 8. So that's 16. Okay. So for any binary sequence, then you can actually put whatever the number, and then it's going to give you the corresponding decimal value. Okay. Now, if I have another okay, look, I'm sorry, I should actually put in here. So this is a 1. This is 2. This is 3. This is 4. And this is 8. So you can put the combination of numbers, and you can do this practice. So what is 0, 0, 0, 0, 1, 1, 1, 1? Then you can just say 0, 0, 0, 1, 1, 1, 1. That's 15. Okay. So this is pretty cool. In the Zybook, this gives you some kind of exercises here. And also we talk about characters, and the character is basically just one symbol. Okay, so it could be A, M, or any number like M. That's a character. So the character actually in Java, if you declare a character, you use char, I'm sorry. Then X. Then X is a character. So you can assign any character like a T, you put a single quote to X. So that means X is a character. Now to import a character, you can also use a scanner, but just keep in mind that's the syntax. You have to use char at 0. Char at 0 after next. Okay, you can use the next method and with char at 0. And we're going to discuss this later. So right now, you just think that that's the syntax we have to use to import the character. Okay. Also, in Java, there are a couple of special character. These called these special character is used to denote some of the things we cannot easily represent using just one keyboard strike. So for example, so you can actually say character A, you can type A, and B, you can type B, and or C, you can C, or space, you can actually press the space bar. But a new line. Now, on the keyboard, you can just press enter, right? But in Java, in the language, if I use the character to represent a new line, how can I do this? It's difficult, right? So in that case, Java actually provide a way, I think not just Java, even Python, just to use an escape, okay, an escape sequence. They basically, escape sequence is a 2-character sequence. So in that case, if I put the n, that's character n, right? But if I want to put a new line, I put the backslash and then n. So these 2 characters represent a new line. Now, if I want to actually press the tab, now on the keyboard, you have a tab key, right? So you can press the tab and you can move forward a couple of space. But if you want to actually use tab in Java, you can use \t that represent tab. Now, single quote, you cannot just simply put the quote in there. Okay, so you have to use \quote. Now, why is this? It's a long story because in Java, if you want to actually represent a string, then you can say hello space word, right? But if I say I don't know. Now, in that case, you cannot simply put a single quote. You have to put the backslash, then single quote. Okay. So for double quote, it's the same. Now, for backslash, if you really want to I want to actually print a backslash as a character, not use a backslash as escape sequence, then you use double backslash. That means the first one is escape, that the second one is a real is the character I want to display. Okay, so a double backslash gonna actually represent just one backslash. Okay, so this is actually, you will find out it's very useful when you actually try to print a sequence of characters in the printer statement in the system.out.print line or .print. You will find a backslash will be very useful. Otherwise, if you don't use the backslash, use this escape sequences, then it will be very confusing. Now let's talk about a string. Now string actually, it sounds very simple. If you want to define a string, then you're going to say, okay, string x. Okay, x is a string. Okay, then I can assign a string, say Brady space Chen. That's my name. Okay, you can do the string. Okay, now when we talk about string, we need to realize that when you declare an integer type in Java, it will actually reserve a space. Okay, now it typically going to it's going to reserve 32 bits space. So reserve for y, and the space is at 32 bits. Okay, now 32 bits. What's the number you can represent with 32 bits? I'll talk about this later, because if it's a 32 bits, so in order to understand this, now let me ask you this question. If I actually try to represent, for 2 bits, for example, how many different numbers can I represent with 2 bits? Each bit you can put the 0 or 1. So that means you can actually put how many numbers you can put. If both are 0, 0 here, 0 here, then 0, 0, right? That means 0. If I put the 0 here, 1 here, that's 1. If I put 1 here, 0 here, what is this number?
2.
2. If I put 1 here, 1 here, that's 3. So that means with 2 bits, you can only represent 4 numbers. Okay, the largest number you can represent is 3. Now, I'm actually completely, ignore the sign, positive or negative. So just think about just a number. Same thing, same kind of question with 8 bits. How many numbers I can represent? Zero, 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 or 0. And I can represent 0, right? 0, 0, 0, 0, 0, 0, 0, 0, 1. 0, 0, 0, 0, 1, 0. Or 1, 0. That's 2. 0, 0, 0, 0, 0, 0, 1, 1. Okay. So I can just do all the combinations. The largest number is 1, 1, 1, 1. Now, what is 1, 1, 1, 1? Let's see. I use so it's a 255. Okay, if it's all 1, that's 255. So basically, with 8 bits, I can represent number from 0, 1, 2, 3, 4, all the way to 255. Okay. So there's a limitation for this. Now, with 32 bits, how many numbers I can represent? So from 0 to 255, that's basically total of 256. And you will find out this is 2 to the 8. Okay. So basically with 232 bits, the largest number, I can represent 2 to the 32 different numbers. The largest number I can represent is 2 to the 32 minus 1. So even though it's a huge number, but it's still limited. Okay. So that's why with int, you can represent a limited, numbers. But for the string, it's a very strange because string is, how much space for integer, 32 bits can be reserved. But for string, how much space I need to reserve? The Java need to reserve for the string type. It's hard to do so, right? Because once I reserve certain large number of space, then I can actually hold certain number of the string of certain size. But for string, the string size could be different, right? So the Brady Chen is a string. Now, if I actually assign another string like x equals I am in computer science, how many characters in this string? Here, it's a 1. For Brady Chen, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But here, 1 space here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. It's a 24 characters, okay, including the space. So for string, it's so difficult to reserve a fixed space because a fixed space can only store a fixed size. Now, the size for the string varies. It could be extremely long. So that's why a string variable is called a reference type. Okay. What the reference type basically means is if I actually declare x as a string, then when I assign Brady Chen to x, then x is reserved as a string type. Okay. When I assign Brady Chen to x, then I actually create another space in the computer memory that stores that string Brady Chen. Now the size of this, I don't know, depending on the size of the Brady Chen is actually, I know it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. So it's a 10 character big, but that's 22, right? So when I actually assign Brady Chen to x, I'm actually not copy Brady Chen into the string, into that space reserved for string. I actually point this string to the object. Okay. Now, when I say point to this, what does that mean? So basically, I actually put the memory address of Brady Chen. So wherever I stored in the memory for Brady Chen, the string. So there must be a memory location. So I just put the memory location inside here. So I actually just, on the other hand, I just point my x to that object called Brady Chen. So when I assign Brady Chen to x, it's not actually copy the Brady Chen, the string, to that space reserved for x. I just point x to that object. Okay, that's called a reference. Now, how the reference is different from the number. So when I assign integer y, when I say y equals 20, so when I declare integer y, then basically in the memory, I create a space, 32-bit space. So in the memory. So when I assign 20 to y, basically I just copy 20 into y, right? But here I don't copy Brady Chen into x. Okay, I just point x to Brady Chen. So that's the difference. And in this case, it's called a reference. Okay, here it's just actually a complete copy of 20 into the space that declared for y. Okay. Okay, so we're going to talk about this more. So now the difference is this. So if I declare string and I declare another string y, so then I assign x Brady chain space to x. Okay, so basically when I declare string x, then I have a memory space reserved for x. That's a string type. And I declare string y, and then I have a memory space declared for string y. And when I assign Brady chain to x, then in Brady chain, I'm going to store somewhere in the memory. When I do the assignment, I basically point x to Brady chain. And then what about this? If I say y equals x, sounds like x is Brady chain now, point to Brady chain now. Now, y equals x, that means this is assignment. I assign y, I assign x to y, right? What does that mean? So the y should have the same value as x, right? So in that case, what does that mean? Do I copy the Brady chain to y? Or I just do point y to Brady chain as well? Now this is what the Java actually does. When I say y equals x, so I assign x to y. Actually, Java just put the y, point y to Brady chain as well. So that means when I assign x to y, that means y gonna point to the same object that the x points to. Okay, y gonna point to the same object x points to. So that's the meaning of y equals x. Now think about the integer. When we talk about two integer, when you say if y is integer, x is integer, then y equals x basically means copy the value of x into y, right? So you just directly copy the value. But here, there's no copy. It's just a reference, Okay, that's the meaning of reference variable, reference type. Okay, so we're going to talk about this more. Because of this, sometimes the string type behaves differently than integer or floating point or character. Okay, now integer, floating points, these are normally, it's typically called a primitive type. Okay, primitive type. Now the string is called reference type, because when you do the copy, most of the time it just point this string variable to the same object that the other string variable actually points to. Any questions on this? Okay, so now forget about reference. Let's actually switch to the import. I mentioned that we can use a scanner to import a string. The way that the import string is use the next, a scanner object dot next. Remember, for integer you use next int. For double you use next double, right? But for string you use next. However, it's a tricky part. So if you want to actually import a string like say hello there. Then if hello and there's a space in between, so then you actually use string 1 equals scan next, string 2 equals next, then string 1 will get hello, string 2 will get there. Okay. But if you do want to actually import the whole string into S1, then you can use the string line. So in that case, if you type hello there, the string 1 will get the whole string, hello there, the whole string, not each of the word. Okay. So that's the next line. Next line going to include the whole line. But next only get the next word. You know, if there's a space, then it will cut over here, and then the next word are going to be imported from next method. Okay. So we'll actually try some of the examples here. Okay. Now integer overflow. I think overflow happens for integer, for floating point number. And so, for example, if I actually type declare integer x, because we're going to reserve a 32 bits for x. Okay. Now, if I assign an extremely big number, much bigger than 32 bits can hold, that's called overflow. Okay, that's called overflow. Now, if you really want to assign a really big integer to a variable, now you can use, you can use another type called long. Okay, so then you can say long y, and then this is going to reserve 64 bits. 64 bits. Double the size. Okay. Now, that's a really big actually increase, because when you actually use 64 bits, you can store a much bigger numbers than the 32 bits can hold. Think about this. So 64 bits is not just double the number, it's just double the size. You're talking about, 62 use x62 digits, binary digits. Now 64 use 64-digit binary. It's a double the length of the number, so it's much bigger. Okay. However, the overflow is still going to happen if you want to import an extremely large number. Okay. So here I gave you a kind of a list. So for integer type, okay, in Java, there are four different data type you can use. Now, the one is byte. Next one is short, int, long. Now, byte by its name. So if byte space my var, this is going to assign my var 8 bits. Now, what does 8 bits mean? The 8 bits can only allows you to, store the number from -128 to +127. That's the range of the number you can support. Okay. Now, if you say byte x, and I put the x equals 200, is outside this range, right? So that's an overflow. Okay. That's an overflow. Okay. For short, you can actually the Java gonna reserve 16 bits memory space for short. And then that's a range you can actually use. Now, the typical int type reserve 32 bits. Now, what's the largest number 32 bits can hold? That's the largest number. I think 2.1 billion something, right? 2.1 billion something. But now, if you want an extremely big number, then you can use 64 bits. Now, that's the largest number, 64 billion. 64 bits can hold. Okay. Now, even actually, if you provide a number which is outside this range, larger than this or smaller than this, you will still get overflow. Okay, data overflow. Now, for the actually floating point number, there are two types. One is called a float type, which basically reserve 32 bits, and double reserve 64 bits. Okay. Now this is going to support the number range. Okay. This is the number range you're going to support. Okay. Still, the computer actual resource is limited. You cannot represent a number of any size, right? So there's always a number that's too big for the computer to handle. So which is expected. So okay. Now Java also supports random numbers. So in many cases, you want to create some kind of a random number. Okay. Random number by its name is that it's a number that's not predictable. So if sometimes it's useful. For example, if you want to play the game with some people, right? So let's just guess what's the next number, and so you can do gambling with other people. Say, what's the next number, and then the next number basically going to be from 0, 1, 2, 3, 4, from 0 to 10. So then I just actually, for example, I put many balls in the bag, and each ball has a number. Like so I just randomly pick a ball and I check the number. So that's basically a random number, right? Because I don't know what's the next number going to be. When I pick a ball, it could be 1, it could be 2, or it could be 9. So you never know. So now the Java actually random number can actually try to simulate that kind of scenario. So you can use a random number generator. I'm not going to talk about this in the class. Please please read the Xi book and do the exercise over there. Now, if you have a question, we can talk about the random number. Now, in a computer, in Java or any actual computer language, when you actually just say, oh, I want to use a random number generator, you call the method called random, and I try to generate a random number. That random number is not really a random number. Okay. It's called a pseudo random number. So it looks like a random number, but it's not. Okay. So when you read it, you will realize, what a pseudo random number is. Because when you generate a random number, they just use some kind of math formula to generate the number, but it makes you make people feel it's just like a really random number, but it's not. Okay, that's just actually things that you need to realize. But in terms of syntax, I'm not going to talk more about this. So pretty much I'm done with the chapter 2. So please actually work on the chapter 2. And also 2.19, section 2.19 just talk about the Java API documentation. So the Java API documentation is a very actually useful resources for us, because no matter how much time we're going to cover for the computer science 2 class, there's no way I can cover every topic in Java. Okay, We can talk about the data type. We can talk about data structures. We can talk about loops. We can talk about branches. We can talk about classes and also inheritance. We can talk about most of the topics, but it's still too, the language still has many actually topics to cover. So it's not easy to do so. So we only pick some very important topics and also lead you to, a way to learn more, because you cannot learn everything in the class. So one of the resources you can use is Java API documentation. This is actually the resources that are created by Oracle. It's called Oracle's Java APIs specification. So basically, if you want to do this, you can basically do that. Let me actually show you. If you want to actually do, you can say, I want to search for Java, any topics. For example, let's say Java math. So basically, you're going to pop out some of the information. This is actually the, it's the website in the docs.oracle.com. Okay, because Java is a language originally used by Oracle. So they, so you can actually check each of this, and you can check all these different method. Okay, so this is ABS, different method. What is ABS? It's absolute value, right? And also we discussed about a square root. Let's see, where's the square root? Yeah, the square root is here. Okay, and we also talk about POW. POW is here. Okay, now the POW, you can see two actually parameters here, A and B. So basically, you're going to provide A to the B. So that's the A to the power B. So but random is another method. Okay, so it's actually a method eventually going to generate some pseudo random number. Okay, so that's the Java API, so you can use. I think that's pretty much all for chapter 2, and then I'm gonna actually try to start with the chapter 3. That's the, now in the class organization, I basically put the first 4 chapters into module 1, because that's the basic topics, and many of these concepts are the same as Python. So that's why I put in module 1. Module 1 include chapter 1, 2, 3, and 4. So in terms of homework assignment, it's going to be 1A, 1B, 1C, and 1D. So that 1 basically means module number, not module 1. So now 3 and 4, basically, 3 basically we talk about the branches. So branch basically is the if statement. So then we're going to check some kind of condition. If the condition is true, then we're going to execute this block of code. And if condition is false, we're going to execute the other block of code. So this gives you the option to either execute the one piece of code or the other piece of code. That's called a branch. And the branch can be achieved using the if statement. The branch is the same. If statement is basically the same as a Python if statement, but the syntax is different. In Python, you use the indentation, but here we use brace, a curly brace to include the block for the if statement. Okay, now that's chapter 3, and in module we call the module 1C, that the C part, module 1C. Now chapter 4 is about a loop. Okay, loop is actually you're going to repeat certain of the operations. Okay, So you have a while loop. So that means if the condition is true, we're going to execute the statements in the block. And then you're going to continue to check the condition in the while loop. If the condition is still true, we're going to actually continue to execute the loop until the condition is no longer true. So that's the while loop. That's loop. So branch and the loop are both called structure. Okay. It's called control structure. So the control structure is basically the basic structures in most of computer languages. Okay. So hopefully we can actually spend one more class, then we finish the module 1. Okay. So the branch, we will talk about the if. There's an if statement or if else statement or if else, if, and else. Okay. So an if statement execute a group of statements. Okay. Just like Python. Now, I'm not going to talk more about this, but I just want to compare this with the Python. So in here, this is actually the nested if statement. So if statement can be continue to use it. So if I have an if, that's a condition statement or expression. It could be true or false. If it's true, then you're going to execute all the statement inside this block. And how you're going to actually, define the block? Use the curly brace. Now that's the difference between the Java and the Python. In Python, you can have an if statement. Okay, you can put some condition here, and then colon, and then you don't have to use the brace. But in Java, you use the indentation. So everything statement here say if x is greater than 0, and then y equals x plus 1. Okay. Now you don't need to actually like a curly, opening and the closing actually braces. You don't have to do this. Okay. But you have to organize the statement using the indentation. So everything actually indent here is this. Now, if I say A equals B plus C, now that means this statement is not part of the block. Now, these two are the block. Okay. So this is actually Python's way to organize the if statement, the block. Now in Java, you use brace. Okay. So now if that's not true, then you're going to check else, and else then is another if statement. Okay. So if user choice equals 1, then you execute this. If it's not, then you check another condition. User choice is 2. It's not 1, but is a 2. If it's 2, then you're going to execute everything inside between these two braces. So you're going to execute everything over here. If it's not true, then you're going to skip again and then jump to else. Okay. So this is actually if statement. Now, if statement, in Python, in Java, you use brace, and you don't care about the indentation. Okay. Even it's not indented, but as far as these statement is between the pair of braces, then that's part of the block. Okay, if block. So so that means if I actually try to write the same statement using Java, the same statement, then I'm going to say if x greater than 0, and then I'm going to put a use brace, and then y equals x plus 1, semicolon. That's another difference. We use semicolon for Java at the end of the statement. Z equals y, semicolon, and then brace. A equals B, plus C. Okay, so that's the Java syntax. Now, this indentation is not necessary. So you can basically just say, okay, you can basically just write this. You can actually put the y equals x plus 1. Still the same, because y equals x plus 1 is still in between these two braces. So that's why, indentation doesn't make any difference. Remember, the Java going to ignore the space. If you put the indentation, you have a couple of space here, Java simply ignore the space. Not the Python. But Python really care about the indentation. If it's not indented like this one, it's not a part of the block. Now here, it's not indented. It's not a part of the block because this is not inside the brace. Inside the braces. Okay, that's the only difference. And other than this, the Java if statement and the Python if statement are basically similar. Okay, logically they are similar. Okay. Now, in the if statement, you basically going to check the condition. Now, so one of the condition is, with all these called relational operators. Okay, equity and the relational operators. An equity basically means you use to compare two numbers, whether they are equal or not. So, for example, you use double equality. The double equal sign. I think we mentioned that before, right? So x equals a equal y equal b, and a equal b. That's different. In here, in math, looks like a equals b, but in here it's assignment. But when you really want to compare a and b, you use double equal. Okay. Now, if you just say, if it's not equal, in math, you're gonna say a is not the same as b. But in Java, you're gonna say a factorial equal b, so that means it's not equal b. Okay. Okay. So you basically say, in this particular case, a not equal 3. That means you just compare x and 3 to see. If x is 4, that means 4 is not equal 3. So that means it's true, right? But in this particular case, if we assume x is 3, so 3 not equal 3, of course it's false. Now 3 not equal 4, yeah, that's true. So that's basically the relational operators. Okay, so that's basically used in if statement, and also if statement can used to actually compare two numbers. Okay, so you can use less than, greater than, or less than equal than, less or equal than, or greater or equal than. So pay attention to this. Less than or equal to. In math, you use this, right? But you cannot put two symbols on the same column. So you have to say less than or equal to. Okay. You cannot say less than or equal to so less than or equal to, that's correct. Greater than or equal to. And you cannot say less than or equal to like this. This is not right. Greater than or equal to, that's not right. Okay. You have to make sure, you write this way. So that's the relational operators. And now this is basically for numbers. You can compare two numbers. Okay. So the number could be equal, a equals b, equal to b, or a less than A is less than B, or A is greater than B, or A less than or equal to B, or greater than or equal to B. So you can do this. Okay. Now, these relational operator can also be used for characters. Okay. So that's something we're going to talk about the next time. But today, I think I'm going to stop right here, and we still have a couple of minutes. And I hope that at the end of each class, like I always try to give you 5 minutes. So then you can have some kind of group meetings and you can talk about things. And you can actually always have a group meeting, because you remember the 3 groups I assigned. You can always have a group meeting after the class, okay? But you can schedule your own time. But I try always to give you some times in the class, maybe leave like 5 minutes. You can start your discussion and to wherever you feel necessary. But my actual next assignment is going to be, I want you to actually look at the chapter 4, the next topic. Or if you look at the module, it's going to be module 1D. Okay, try to actually look at the chapter 4 or module 1D to see to discuss. If you have any questions, you can something you're still not sure or you are not clear, you can first talk to your group members, and then you can come up together with some questions. Okay, I want you to do that.
I have a quick question.
Yes.
Is module 1C still due tonight?
Module 1C, yes.
Okay.
Yes. Okay. 1C, yes. Sometimes because most of the exercise is basically right after the topics, so you can actually do this. But I want you to actually start with this topic. So I'm sorry that we're running out of time today, but that's not my intention. So next time, I hope that I can always reserve some times for you to discuss. Okay, but I can actually post the assignment on the Blackboard like a group discussion. So if it's running out of time right now, you can use some other time. You can use my link, the link I provide, but you can also discuss and create your own Google Meet link. It's so quick, so easy. Okay.
Okay, so do you want us to meet before next class with our groups?
I hope so. Yeah, I
Okay.
think it's yeah.
Are we supposed to start doing any work or just creating questions that we
Just
have?
creating question. That's basically, we try to do this. This is the first assignment, so that's why I don't want to make it so tough. So just put together. If you have any issues you want to bring into the class, then just do so. Okay.
Oh, and Professor,
Yes.
that programming lab that you posted on Blackboard, is that still due this Friday?
At this moment, yeah, I still want to keep as on Friday, but you can also discuss any issues about these programming lab assignments in your group meeting. So any issues you have, you can discuss in your group actually meeting, and you can post this question. You can post any of the problems on the discussion forum, in a Blackboard. Yeah, I know that. So we may not be able to complete the whole topics in this week. So probably I'm gonna extend the due date to next week, maybe next Monday. Next Monday is actually a holiday, but I can still actually put the due date. So I gave you, we can discuss on Friday's class, and I gave you additional weekend to work on these, and so you can actually submit the work next week. So, but at this moment, is to stick with the 12th of February, but as you can see that most of the time I may actually adjust the due date. Okay, so let's see. Just try to actually do that discussion, and hopefully you can come up with some questions and issues and anything you want to talk about. And I just want to get some feedback from you, because I don't want just keep talking and talking and without notice what happens with you. So okay, so any other questions? Okay, let me actually stop the recording.